So welcome to the workshop, everyone. Today we are going to talk about building custom linting for RuboCop and extending what RuboCop is capable of out of the box. And so, yeah, like I said, if you don't have the repo, go ahead and get it cloned now. And we will do a little bit of talking about what we're going to cover, and then we're going to jump into code fairly shortly. One thing that the folks doing recording wanted me to ask is if you have questions, to just ask them at one of the mics in the stands. We're holding one of them, but we'll put it back. So if you have a question, just come up to the mic and ask it. So let's see. A little bit about us. My name's Scott Moore. I'm a software developer. I've been doing this for 9 or 10 years, something like that. I've done kind of a little bit of everything. I've been a beginner many times. And I've been working in Ruby for the last couple of years. And with me is Carrie.
Hi, I'm Carrie Silva. I am a back-end developer. I work with Scott. I was previously a physics and biology high school teacher, and I made a career change and jumped over here to tech about maybe 3 or 4 years ago. And I'll just be kind of walking around for support. If you guys have any questions, I'll be available for you.
Cool, and so we both work at a company called Sondermind, which is here in Denver. Sondermind builds software to support mental health care and therapy, both virtual and in person. And we are hiring, so feel free to grab us after the talk if you want to chat about working there. Like everyone else, we are hiring. Cool, so just really quickly, just want to talk through what we're going to cover here. This is not going to be like a deep dive into parser implementation or, getting into like the hairy details of how those tools work. This is definitely focused on things that are kind of at the top level of how we use RuboCop. We're going to touch a little bit on what those tools like parser provide for us, but we're not going to go way far into it, just largely for time. So what we are going to work on is kind of a toy problem to just sort of get you thinking about what's possible with custom linters and show you sort of the basics of how to set one up. And hopefully while you're working on this, I'd encourage you to think about problems that you have in your code base that this might actually help with improving. So before we go too much further, would y'all mind just raising hands, like who's familiar with RuboCop, works with it day to day, or uses it in their code base? So most folks? Cool. Cool, and then just like roughly for Ruby experience in general, can we do the thing raise your hand if you've done at least a year of Ruby, and then just keep it up if you've done 5 years, 10, anybody? Okay, somewhere around there. Okay, cool. Right on. So let's see. Let's just quickly cover, we're not going to, I'm assuming that everyone at least has heard of RuboCop, but RuboCop is a linter. It does formatting. It helps us to autocorrect stylistic issues in our code and to steer the code towards kind of a common ground as far as a style guide and best practices, which are things that you can configure and is just generally meant to provide like one way to do things and hopefully some autocorrection and things like that to help us get there automatically. So that's great, and a lot of places use RuboCop. It's fairly common. I would say it's the norm for this kind of tool. And so that kind of raises a question of like, why do we need to write something custom if we have this tool that's there and follows a community style guide? So it really just comes down to things that are unique to your code base. So these are examples from Sondermind, things that we've been asked to do in RuboCop. And so things like right now we are working on a project to get our many environment variables in our application under control. And so we have a linter, a cop that prevents you from introducing new environment variables without documenting them. And so we just check against a file where the documents live, or the documentation lives for those, and then we flag any PR that doesn't add documentation if it introduces a new variable. So that's something that's just specific to us, and that's the kind of problem that it's really good at solving, because you can really quickly do that and then enforce that quality issue, forevermore. So then what is RuboCop actually doing when it lints our code? So what RuboCop does is it leans on this library called parser. And so parser is doing the same kind of work that you would do when you're like compiling code. It is looking at the actual source code text that you've written and splitting that into tokens, which we'll see. And don't worry, this part of the talk is going to be quick, and we're going to spend a lot more time like actually looking at this stuff in code. And it'll hopefully, if it's not clear now, when we're actually working on it, it'll be clear. So we're splitting it into tokens, and then we are converting that into an abstract syntax tree. And then RuboCop adds a lot of tooling to make it easier to work with the output of that underlying library. And there's much more than that, but just to keep things moving, that's the very basics. So what's an abstract syntax tree? Well, it's a tree that represents the structure of our source code. So we have that lexer is that first part that reads the source code into tokens, and then we have the relationships between them so that we can programmatically look at the relationship between different parts of our source code. Again, flying past this, it'll make more sense in code. So this is the output of a utility that you get with parser called Rubyparse. And this is the abstract syntax tree for a very, very small bit of Ruby code. So you can see that we have a method, no arguments, and just a couple puts calls there. And the Ruby parser is using indentation to show us the relationship, like the structure of these parts of the code. It's also showing us things that are implicit, so like the args, even though we didn't define any, it knows that there are some there, and it shows us the implicit begin, things like that. So it's a little bit more than what we just see in source code. So that is kind of the core of what RuboCop works with. And essentially, that's the rationale for RuboCop. Like, if that's what you get for 4 lines of code, then doing this kind of thing where you are looking at this and trying to, like, if you were trying to, treat this as like a string or like iterate through this as a tree by looking at these like indentation levels or something, if you just had this raw, it would be pretty painful to try to do anything with it. And things like parser and RuboCop give us the tools to work with that more easily, and that's why we are here. So, okay, this is just me shilling my company again. So, with that said, look at my notes. We are now ready to start coding. So, let's switch over to, what we want to look at is we want to get our repo cloned and do a bundle install. And then we want to take a look at the instructions.markdown file. And that is going to be a step-by-step guide to work through this repo. So a couple things to keep in mind as we're writing code here. Each of these parts of this process of building this are split up into steps, and the steps are just directories. And all we're doing when we say, you'll see references to like switching steps, and there's a script called switch step. And all that's really doing is we have our RuboCop configuration file, our RuboCop.yaml, and we're just pointing it to a different directory. This is like there's not a lot of magic here. So that's all we're doing. So if you are working on something and it's not working for you, and you just want to kind of move on and get through that, you can just switch to the next step, and each one builds on the next. And so the code to get through each step will be in the next one. So if it's like, oh, I'm trying to iterate through this thing, and I'm just not missing something, not getting it right, you can just skip ahead. So that's always an option. So yeah, we're going to quickly take a look at the folder structure here and kind of how things are laid out for just a minute. And then what we are shooting for is about half an hour of the first 3 steps. And then the last 2 are something, they're going to cover something called the node pattern matcher in RuboCop, which is a fairly common thing to use in writing linters. So we do want to leave more time for that. So we're going to shoot for about 45 minutes on those last 2 steps. And then hopefully we'll end up with, 5-ish minutes if there's like general questions. But again, yeah, if something doesn't make sense, feel free to just step up to the microphone. And also, like if we get to the end and we're out of time and you just want to, get through the last bit of it, I'll hang out here for 15, 20 minutes. So we can keep going then, and you can always ask questions in Discord, and I'll be on there for as long as the server's up. And you can raise issues in the repo too if something doesn't make sense. So let's get started. Basically, whoa, I almost flipped my laptop over. It's a good start. The main things that we're looking at here is we have a Ruby app that prints strings, which is pretty cool. And that's really all it does. And that's the thing that we're going to lint. So we don't care that much about like what's actually happening here. This is our Poetry Slam app. So we have that. And then we have our custom cops, which are in these different directories that represent the different phases of building them. So if you have just cloned everything, you should be on step 1. And what we're going to do is really just kind of look at the data structure that we get back from RuboCop when we are linting something. So one moment while I read the instructions too, even though I wrote them a couple days ago. Essentially, just out of the box, we should be able to just run, let me make sure I don't have anything. We should be able to just run RuboCop after you've done a bundle install. So could everyone try that and just make sure that we're able to do kind of that first level of things? And you can always run, RuboCop also has a debug flag. And I believe in the instructions I specify that. And that'll just give you more context about what's happening there. So far so good? Things are working? Good. Over the first hurdle of things just catching fire. So we inspected some files, nothing was detected, and that makes sense because our step 1 is not doing anything, right? We're just an empty class here. So what we're gonna do is RuboCop has these callbacks that we can hook into that happen in the life cycle of like a linting run. Everything in RuboCop is a police metaphor of one kind or another, and so RuboCop calls it an investigation. So what we are going to look at here is we just want to look at something that happens when we start linting a file. And so that callback is going to be the on new investigation. And so if we just define an on new investigation method, then that will get called when we run RuboCop. So if we do that now in our step 1 and just add that, and we do a binding.pry in there, then we should be able to take a look at what RuboCop has provided. And the main thing that we're going to look at in this is called processed source. And so this, hopefully, if you hop into this in your debugger, is going to make some sense of a little bit of what we talked about in the slides. So what this is providing is an abstract syntax tree of a couple of the files. So this is our gem file. It's actually, it might be best if we just quit out of this particular one and look at the process source for our app. So is everyone able to see process source and looking at what we're getting back there? Good, thumbs up, awesome. So we've got an abstract syntax tree. We can see each of our methods. We've got our calls here, pretty exciting stuff. This is where we start to get into more of the sort of like additional context that RuboCop provides. So we have things like comments that are not part of the syntax tree itself. We also have like broken this into specific lines. We have a raw source, so on and so on. And then here we can see each of the tokens and the range in the source file that parser saw them in. So that's including things like new lines. And also it's able to like see the type of each of these tokens that you've provided. So strings of comments and things like that. So this is kind of the lower level of that parser tool that RuboCop is using. And then it's composing all of this into something that we can actually work with a little bit more effectively. So yeah, I would just give this a scroll through, kind of see what's available. The thing that we care about here is the process source. And the process source is going to have something called the AST with comments. So I don't want to make this disclaimer too many times, but I just want to acknowledge this is kind of a weird idea for something to lint. Like normally you don't care about like the syllable count of your comments. So you may not like look at the AST with comments all that frequently, but you can imagine how you could use something like this to build something like Yard, where you have like comments that actually have meaning that get parsed into HTML documentation or something like that. So when we look at the AST with comments, we see that it has associated the comments with the methods that they're above. And so this is going to provide us with a collection of hashes that are keys and then values that are arrays of these parser source comments. So for step one, we just want to take a look at that and print out the text of these comments. And so there's more detail on that in the instructions file. But essentially what we're looking at is we want to iterate through the AST with comments that we got and then print out anything that is in that value for each of those key value pairs that's in the AST with comments. So let's see if yeah, so there should be a little bit more detail around getting those, but what I would do is just spend, let's say, 5-ish minutes and just see if we can just dump out the comments when we do a RuboCop run. And if you are running into trouble, Kari can give you a hand. Or
Hey there. So I am running RuboCop with the changes that I think that you put in there in haiku comments, but I'm not getting a binding pry. It's like it's not executing that callback.
okay, Kari, do you mind taking a crack at it? Thanks. Do you mind asking at the mic, just so it gets caught?
When I ran the process source runs fine, but when I ran the AST with comments, I was just getting an empty hash. I don't know.
Yeah, sorry, I should have been clear about that. I didn't really catch what that was. We're linting 2 files here. So I'll tell you what, you know what is actually going to help? When you're linting, yeah, sorry, this is my bad. I should have ignored this, but you're probably looking at the gem file. So if you run your RuboCop command and you just run it directly against app.rb, that'll just limit it to that file. And that's gonna be an easier way to deal with this, because then you're not gonna have to like step through each pry session. So sorry about that, but yeah, just run it against app.rb, and that should drop you into the code that we actually care about. So give that a shot, please, and let me know what you find.
Can you just maybe walk through the AST with comments, like what we're supposed to be reading on that?
Sure. So, yeah, if we, and I'm going to cheat a little bit too, because this is more just to like, it's really more just about looking at like this structure here. But if we take a look at the, each of these, elements that are in this AST with comments, if we just look at, let's see, you can do first, I think. So if we look at a single one, it's an abstract syntax tree of a method. So that first part is going to be a hash that contains it's going to be an AST node type that we get from RuboCop, I believe. And then the second, the value of that key value pair is going to be an array of parser comments. And so if we look at the AST with comments and then we just do like values against that, we can see that that gives us the values from each of those key value pairs. So we've just kind of discarded the actual abstract syntax trees that the comments were attached to, and now we're just looking at a list of the parser comments. And then again, like I said, if you are getting the feeling that like you're kind of there but you're just like missing one step, you can always just look at the next step in here. And so if we look at step 2, if this part is boring and you want to just get to node patterns, then we're essentially just saying, let's take a look at the AST with comments, and then for each value, we're just going to call text on it. And the comments objects from parser will just respond to text, and so we can just dump that out. So the S is an S expression, which if you are familiar with Lisp, might be familiar. I'm not familiar with Lisp, so it's basically it's like a it's a kind of like if you've ever worked with like reverse notation for math, it's a notation that describes the like callers and callees in the code, and then it just uses indentation there. So the S is just indicating that it's an S expression, which is just a one way of representing that tree. So we are going to kind of, when we look at node patterns, we're kind of going to look at like the other side of that, which is providing a pattern that matches against those.
So on the comment blocks, when it prints them out, it always will print out all the blocks above a certain function call, and it will group them all together as 3 independent comments. Is that how it does that?
Yeah, so parser should take any of the comments and try to associate them by looking at the ranges that it finds them in the source code. And so it should be able to see that when you write a comment above a method, that should be the value of that key value pair.
So what about in this file here, like the haiku comments file? We have that like 4 comment block with no method underneath it. Would those come through attached to a method? I mean, attached to nothing, or like as independent blocks? How would
I'm
those
not
come
sure,
through?
actually. I
Okay.
haven't tried it, but we could just try it real quick. So if we just throw a comment into the app, and then we look at the processed source AST with comments. So that one, it's still just getting associated with the last, or the next line that it finds, kind of regardless. So let's try it just at the end of the file. And so, yeah, I think it just, yeah, I think it just tossed that comment. I'm not sure if it's possible to, if there's like another place we could look, but I think that, yeah, it just like did not represent that in the AST at all.
Awesome. Thank you.
You may, I don't know, I'm not sure what it would look like in a class, but. All right, so let's give it another minute or two, and then we can just switch over to step 2, and then take a look at single nodes. So in like, yeah, 1 or 2 minutes. All right, so just in the interest of time, let's switch to the next step. Hopefully we've all had a chance to look around at the process source a little bit and kind of see what gets provided there. So now what we're going to do is we're going to start looking at things on a more of like a per node level rather than just looking at the entire source at once. And so this is a little bit more common when you are working with linters, is you're more frequently going to be just looking at like smaller sections of your source code at one time. So if you could just go ahead and point your RuboCop.yaml to step 2, so you can either run the switch to step 2, so / switch to step, and then just give it a 2, or you can just edit the RuboCop file directly and point it to the step 2 directory, just so that it's running that. And then what we're going to do is we're going to use a callback that is called onDef. And so these are, again, like callbacks that happen at a little bit more granular level. So you have things like onSend, which is just going to happen on any instance of like a method being sent or message being sent. And then onDef is going to happen on method definitions. So if we define an onDef, and so now we're in our step 2 cop. If we define an onDef and pass it a node, that's going to get called on every method definition in our source file. So then just quickly, if we throw in a debugging statement here and we run RuboCop against our app file again, then we see that we should have a node, and this one is the first method definition. And then if we move forward, there's our second method definition, right, and so on. And so just for each of these methods, this callback is going to run, and it's going to provide us with the node. Now, we do still have access to the processed source at this point. And so what we can do is we can, because you notice that when we look at the node here, we don't have the comments, right? We're just looking at the AST and not the AST with comments. So in order to get the comments for each node, which is kind of what we care about, then what we're going to do is we're just going to select from the AST with comments. I'm going to see if I can remember this off the top of my head, but it is also in step 3. Remember, if you just need to grab this line. So we're looking, remember, at I've got this in the comments here, but we're looking at a key value hash that looks like this. It's got a node, and then it's got an array. And so, and now we're looking at each node, like per node now. And so we can say, in our process source, we have a source node, and then a source comment array. And we're going to select where the source node is equal to the node that we're looking at now. And that gives us something a little bit different. So now we actually have our node and our comment array. And so this is one that it's up to you. If this is like super easy for you to do, just bust it out. Or if you want to just grab it from the step 3 file, that may save you some time. But what I'd say is maybe spend 5 or 10 minutes and hop in there with a debugging statement again and try to grab just the node from your AST with comments where it matches the node that you are looking at now in your onDef. Or sorry, yes, onDef, excuse me. So give that a few minutes, just see if you can pull that from the AST with comments. And I'll just leave that up there if you want to grab it. All right, how are we doing? Are we seeing the node that we're looking at in this callback and seeing the comments for it? I feel like I saw some nods and some shut up, I'm still coding. Okay, cool. So the next thing that we want to do in step 2 is once we've looked at this, we've grabbed this with a select, and now we have what I'm calling our node with comments from our AST with comments. The first thing we want to do is we want to see if it's empty. And that just means if we get an empty hash back from that, it just means that we're looking at a node that doesn't have any comments. And so we can just return at that point and bail out and move on to the next node. So just add a return if your node with comments is empty. Because just for this workshop, we're just going to ignore that. Like if something doesn't have comments, we're just not going to bother with it. So once we have added that return, so that we're not going to have problems with anything that doesn't have a comment, we should be able to take a look at the node with comments and remember that it's going to be in this format of a node and then an array of comments. So for this step, what we want to do is we want to have RuboCop throw an offense on the file if that array of comments doesn't have 3 lines in it, because you can't write a haiku without 3 lines, presumably. I don't actually know that much about poetry. So we're going to count the number of comments. And so our node with comments, so if we look at the node with comments now, actually let's just do this in pry. So if we hop out of this run and jump in again, we now have a node with comments, and we can say node with comments values, and that will give us our I think we might want values first here. And that's going to give us our array. So pretty simple. Just get that and the size. So if we're looking at something like using this node with comments values first count, then we need to tell RuboCop that if the count is not what we expect it to be, then we want to add an offense. And so when you run RuboCop and it gives you the nice messages that are like, you have trailing white space on line whatever, and it shows you like a little snippet of code, that's all handled by add offense. So if you just add an offense in your cop, then RuboCop, and you pass it a node, that's important, RuboCop will map that back to where it lives in your source file. And so that's really all you need to do. Like you don't need to provide much more context than that. It is important to remember when you're writing this kind of stuff that your fellow developers are going to be looking at it. So like put the time in to write a nice message that hopefully helps them to fix whatever is wrong. Don't just say like this is broken. And really ideally, RuboCop gives you the capability to add autocorrect to your cops. So in a best case scenario, you would be able to just say, look, like this is our style guide preference, just run autocorrect and it'll do it for you. It's going to be fairly hard to autocorrect comments to be in haiku format, but if you do that, that's really cool. So bonus points for that. So all we're going to do is just call add offense. and we already have the node, right, because we're in the onDef for that node. And then we can just give it a message, and we can say the comment for this method did not have 3 lines, and just say unless node with comments values first count is equal to 3. So go ahead and add an offense to your cop, and then when you've done that, run RuboCop against your app file again and see what happens. All right, how are we feeling? Ready to move on? Next step? Cool. So let's go ahead and switch to step 3. Oh, and I just want to, if you are not following along at home, what we're going to get when we add the add offense, like I said, it's going to tie the node that you flagged back to source code and show your developer something meaningful. And it's going to like actually highlight where it found that in the code, and then it's going to just give them whatever message you provided. And so that's your opportunity to have some kind of developer experience baked in there and give them some kind of hint as to like the right way to do this. So you should see something like this when you run this. And we don't, just to keep things moving, you could like actually dump the comment in there. That would probably be a little more helpful. So we're not going to worry about it for this step. So let's go ahead and switch to step 3. So in step 3, which hopefully is a small iteration on, it has a lot more code, but it's hopefully a small iteration on step 2, we're actually going to enforce that we have a 575 syllable count, and we're not going to write syllable counting code ourselves, because that sounds hard. And so there's a few things that have been added here just as kind of helpers. So you have this syllables method, so you can pass that a string, and that will return an integer of the number of syllables in the string. It's sometimes wrong. If it counts something and you disagree with it, you're right, and it's just this library that I'm using sometimes has things that don't quite make sense. There's also a message for method that we can use that just gives us like a little bit prettier output. Like I said, printing that comment so that if you're telling someone, hey, you need to rewrite this comment, you're actually showing them like what they wrote so that it's a little bit clearer what they need to do. So what we're going to do in this step is we just want to check the syllable count of each of these comment objects that we are getting back from parser. And remember that the comments themselves are not strings. You need to call the text method on them to get their contents. You don't need to do any like cleanup. We should be able to just call the syllables count, and it'll just take care of like removing any characters that are not just strings, or just not just characters or alphabetic characters. I think that made sense, hopefully.
A
Question.
quick question. Does add offense return when you call it? Like, can I call multiple offenses on the same on def call?
You can.
And those will print out 2 separate offenses in the RuboCop file?
Yeah, you should be able to do that. And so I can see that you might like sometimes not want to. You might want to just like return add offense if it's something. Yeah, you may not want to, but you probably do want to like stack your offenses that way, because otherwise someone is going to fix one offense, then run it again and get another. And so yeah,
Okay.
you can, and you'll see that in RuboCop where I don't know, I'm blanking on an example, but you can do it.
So like in this one, we would still want to check the syllable count even if there was only 1 line of comments, and then we'd want to tell them you only have 1 line of comments and it doesn't match the syllable count?
So in this one, yeah, there's 2 ways you could do it. You could just say return add offense. So I guess I would suggest doing that. Just start with just returning the line count offense, and then if there are 3 lines, then add another offense if they don't have the right number of syllables. That's what I would suggest. I wouldn't suggest you do that for the reason I just talked about. Like, you don't want to make someone take 2 cycles through. You could also just do like a safe navigation operator or something, and just check the comment strings that way. And then if they're not there, then it should still work correctly.
Okay, thanks. And then do you know, does add offense return just nil, or does it return the values? Because it's kind of printing it out to the console, so I don't know if it.
I'm not sure.
Okay, thanks.
I'll poke around and see what I can find out. All right, I want to give it another, let's say like another 3 or 4 minutes, and then we'll move on to the weird part. All right, how are we feeling out there? Do we want more time on this, or do you want to look at node patterns? I'll assume that means node patterns. Cool. So, and just again, remember, you can just switch and it'll backfill this stuff. So you can always come back to the repo if you want to dig into a particular step. So what we want to do is we want to switch to step 4. And what we're going to look at is something called the node pattern DSL, which is a pattern language for matching abstract syntax trees. And you'll see this a lot in like the newer RuboCop default cops. And this gets back to the earlier bit where we were talking about how these like larger ASTs are pretty hard to like walk through, right? And if you're writing code that steps through them to try to find, things that are like deeply nested, or like you don't want to call this method from that method, something like that, it gets like pretty verbose to try to do that. And so the node pattern is meant to give you something that's a little more terse and can express a pattern in an AST a little bit more cleanly. But like all terse things, it can be kind of confusing at first. So there is a resources section in the bottom of the README, and there's a link to this thing called Node Pattern Debugger. And this is kind of a lifesaver if you're writing a lot of these. So if we take a look at what this provides, it should look similar to like if you've used like an online regular expressions tester. And so what it lets you do is it lets you test out these patterns. And what we're going to do with this pattern is we're going to tell RuboCop to just match on anything that matches this pattern. And that way we can limit our linting to like very specific patterns in the source code. And in the case of our workshop, what we're going to do, and I think this might take most of the rest of our time, but what we're going to do is we're going to try to match on methods that start with poetic. We've decided that poetic methods need to be linted and non-poetic methods don't. And I want you to all ignore the fact that you have the method name available in the node and you could just check that right there. That's not the point. The point is to mess around with node patterns. So this is like not the way you would necessarily solve this problem if you were in a hurry, but hopefully we'll show you a little bit about node patterns. So just taking a look at what we can pass to that pattern. What I think is helpful, and hopefully is helpful to y'all, is if you look at these patterns, they have a lot of things that are like similar to regular expressions, like a lot of like characters that will behave in ways that may be somewhat familiar. The main ones that we're going to look at are the underscore, which is used as just like a single node wildcard. And then we're going to look at, there's a triple dot that will match against like multiple nodes, and that's another wildcard character. And in this case, if we get to the next step, there's a way that you can just search within like any descendants of a node, and that's the backtick. There's a little bit of a reference here. I would definitely recommend pulling this up when you get started on coding here. But I'm just going to show you a little bit of like how it's walking through this code. So if we look at if we just use our single wildcards and we just say, hey, just four nodes, then it matches this code. And if we use the match operator here, which is the $, then the matches, this little card here, will show us like what it's actually seeing. And so it's looking at things like in the order that they're provided in the AST, which is down here. And this tool is really cool, but this is just written by one of the RuboCop maintainers, and it's not like super polished. So it doesn't give you the indentation that you would normally see with that AST, so it's a little hard to read. But what I find is helpful is if you just put in the code that you're trying to match and just look through by looking at like each of these individual elements and then calling the match operator on it. And so then like naming them something, if as long as it's still prefixed with the underscore, it'll still act as a wildcard. And so we can just say, okay, well, this is the def keyword, right? And so then let's toss that match out. And then let's look at what's next. And we can see that's example. So that is the method name. And then we match again, and we can see that those are the arguments. So args node, that's another, it's an AST in there that we could step into. And then we match it again, and we see that that's actually the method body. So this wildcard operator here is matching the entire method body. So what we're going to do is we're going to try to write a pattern matcher that matches, that gets the method name, and then, so I would just try to do that in the node debugger first, and then, unfortunately, this is where my cobbled together selection of tools doesn't fully mesh. What we're gonna do is we're going to actually pass that match to a method. So what you can do in normal life that you can't do in this tool is you can say, like, is this poetic? And that will just take that node that it matched against and pass it to a method that you defined called poetic. And so that's how you can say, like, you could do kind of like a, I'm trying to think of a good example besides this very contrived one. But if you like wanted to say like never call this method from our utilities when you're in like this part of the code base, you could do it this way by saying like, well, pass it to this function that checks to see if the method name you called matches some pattern. And again, method names are maybe not the best example, but it lets you define custom logic that you can just plug into the node pattern. So unfortunately, this tool doesn't know what poetic is. So what I would suggest you do is just grab, or really any method in here, and just go through the matches using that $, and just take a look at like what it actually matches against. And then and I would just name them. I find it's really helpful to just give them a name, prefix it with an underscore so it still matches, and just see like what the structure is, and start with that. And when you've got to the point where you're matching that in here, then if you look at step 4, there is already a call to poetic. And let's see. Oh, is that right? I'm sorry, this is a bug. On that line 33, we want to call the pattern matcher, I believe, against the node. And that will do a check against that pattern matching if you define a node matcher. And so that's what's commented out up here. So we're going to define a node matcher and then just pass it a pattern as a string. And then it will return true if you match against that pattern when you pass it a node. And it'll just return nil otherwise. So yeah, I'll just go ahead, walk through some method in that tool that's linked from the README, and then it's also in the instructions, I believe. Yes, if you look for the string, a fun tool, I hope you agree this is fun, then open that up, walk through some, and see if you can like see the structure of them and just name things as you find them. Let's start with that. So I want to just give it another like 3 or 4 minutes to just kind of play around with node patterns, and then we'll hop in and start to like drop this into the actual cop. Okay. Sure thing. So if you define a def node matcher, and then you give it a symbol, and then a string. So what RuboCop will do is it'll provide a method that you can pass a node to, and the method will be defined with the symbol that you give it, and then it will match against that pattern. So actually, let's just hop in. It's about time to get close to the end here. So what we have here is an example. So we call def node matcher. We say we're going to call this poetic method, and we're going to pass it this pattern. And so the pattern is a def keyword followed by a method name, followed by method args, and a method body. And again, the underscore is a wildcard, and then anything we provide after that is just kind of for our convenience when we're looking at it. So this is going to match anything that has a def method name args body, which is any method. Because we're not really saying anything specific about the method body or anything, really. And then when we call that in our cop, we're just saying, because here we only want to lint things that are poetic, we're just saying, return unless it's poetic. And then we're passing it the node. And one other thing that I noticed, which I think.
So then what's the advantage of that compared to what we did in the last step, where we just return unless poetic without using the node matcher?
You mess around with node patterns. Again, it's kind of a toy, but
It's doing the same thing.
it's doing the same thing. Yeah, but we're gonna do it without, instead of looking at the node.method name, which would be way easier, but wouldn't tell you anything about node patterns. Okay. We're just gonna do it because it's hopefully a fairly simple node pattern. And But yeah, you probably wouldn't do it this way. This is kind of a weird way to do it.
Okay, cool. Thank you. That makes sense.
Okay, cool. So then let's see, what we're going to do is we want to just limit the nodes that we're checking to the ones that return true from the node pattern matcher that we just defined. And so we can just say, in our cop, we can just say like, hey, return unless it's a poetic method. So when we look at our app, we have a method called poetic setup, poetic execute, and cleanup. And we don't care about cleanup. It's not poetic, so it doesn't need haiku comments. So we are going to now pass the node to our pattern matcher, and then we're going to change our, well, we can get to this later. We do need to change that poetic a little bit as well. So let's just hop in with a debugger, and if we do a run through, and now we can just say poetic method node. Well, let's look at our node first. So this is poetic setup. So we say, is that a poetic method? And it says true. Well, that's fine, but what if we get to the cleanup node and we say, is this a poetic method? It also says true, which is not what we want. And the reason it says true is because this pattern matcher is going to match any method definition, right? So what we're going to do to limit it is we're going to try and match what we've described here, a def node that responds true to the poetic method with true, with any number of args and with anything in the method body. And so we have our def keyword, that's good. What we're going to just do now is to call that method is we're just going to replace the identifier in our pattern with the call and with the hash to indicate that it's a method we want to call. And if I did this right, and we exit, so now we say node is poetic setup, and we say poetic method. This is a part where I'll look foolish if it doesn't work, more foolish. And it says, no, it doesn't have a method name. I think because I didn't actually need to change this. So ignore that because your file will not have that change in it. Try one more time. So our node, we say poetic method, which is our node pattern matcher. And it says it's true. That's fine. But it said that before. So we're going to just hop to our cleanup node, and now is the part where I look foolish. And we see that poetic method returns nil. And the reason for that is that although it's a def with method args and a method body, it responds false to poetic. And so this node pattern matcher will filter it out. And so it's only going to return, this method that we get from this through RuboCop is going to return true only if it matches whatever our helper function is. Does that track mostly? Cool. So there's another step in here, and it's has instructions as well, and I would encourage you to dig into it. It's a little bit more involved node pattern exercise, dropping into the method body, and we're going to look for any call to puts with an argument that contains the string poet, so any poetic puts. So I would encourage you to take a look at it, and please feel free to ask me questions in Discord, or if something seems broken, just throw an issue on GitHub. Or if you want to just hang out, I'll hang out for a little bit and we can kind of poke around with that too if you want. But I just also wanted to leave, we have 4.5 minutes, so if anyone has questions or anything they want to ask about or comment about, this would be the time. No, and you mean in like the next,
On that line 13?
yeah, so it doesn't matter. If you prefix it with the underscore, then RuboCop ignores everything after that. So like we could just say, you know, anything, really. So
The underscore's a wildcard.
yeah, and it's really just for the convenience of knowing like, how does this pattern match to like what we're actually looking at? But RuboCop doesn't care. Similarly, in a case like this, you know, we could just say like, hey, there's a keyword, there's a def keyword. We probably actually do want to just say like, it's a def, like no underscore. Like we don't want this to somehow get run against something else. And then once we've agreed that the method name is poetic, we could just use the ... to say like, and then followed by something. And that's like a multi-item wildcard. And we just don't care at that point. Like once we've looked at the method name and examined that, we can throw away the rest of whatever we're matching on. So we could do that. It's just that, you know, if this is the first time you're looking at a node pattern, like this is a little more opaque. So that's the only reason to have those names in there. And I just personally, you know, trying to work on this stuff, I find it a lot more, I find it helpful to use something like this, or even just like a binding pry where you're just calling that node pattern matcher, and just like giving it names as I work through like, okay, now I've like drilled down into this, this part of it, et cetera. I'm going to like name these so that I know where I am, and I don't just have like a huge string of like, you know, underscores that means something. Yeah, so the example we brought up earlier of like not doing environment variables, we would use like onsend for that, and we're looking for calls to env or envied with arguments. So you would say like, you know, a call that is either env or envied, checking in your onsend, where so the receiver is going to be env or envied, and then you're using really like any call against that where you can't match the, like for method it would be, or for envied it would be a method name. So you go look in your like documentation and say, hey, like we just saw a send of like some method against envied, and then we're not finding it in our like documentation lookup. So for that case, it would be onsend. You know, on def would be something like if you want to like ban the use of some message and say like never use public send in our code base or something like that. You would probably want to do that against like just the on def matcher. You could also do, like I'm pretty sure for RuboCop, if you're looking at something that's like per file, that's when you would use like the on new investigation, because you could look at things like, you know, line count or something like that in a file. So it just depends on like what you're trying to actually check for. But the main ones that I've seen are on send and on def. So.
Do you do anything else other than the environment variable check? Like what other cool RuboCop custom calls do you guys have that are useful?
I think the next one that we're going to work on is we have like a standard that people shouldn't create database tables without like table level comments in Postgres. And so making sure that people aren't calling create table in a migration without providing a comment to it. But what I would also check out is if you look in the resources section, there's an Evil Martians blog post that talks through a lot of this. It's longer and more in depth than this and gets into like tests and stuff like that for your cops. But one of the things that it has is a list of GitHub repositories of companies that are using these. So like Airbnb has a bunch of different things that they check for example, and there's maybe a dozen different companies in there that have their like custom cop repos available, and you can kind of see what other people are using these for.
Cool. So. That's awesome. Thank you so much.
Sure thing. Cool, well, thanks everyone. That's all I've got, but if you would like to hang out and talk through more of it, I'll hang out for a few minutes. Thanks very much.